Welcome to another episode of The Science Show. Today we will be showing the importance of the scientific method in science. Now before we start, we must always remember the most crucial thing: protection.
We must all understand the fundamentals. Quantitative and qualitative observations and interpretations are two types of data we can conceive. Quantitative, as it is suggested, relies on hard, solid data that can be measured, such as numbers. For example, we can say, Will is 6 feet tall. That is a quantitative data. Now, qualitative data is any data that is described but not actually measured. For example, we can say that Will is really, really fat. That is qualitative data. As scientists, we prefer quantitative data as it can be manipulated and analyzed for further use.
Let us look first into measurement. As you can see, there are many things that may be measured, such as mass, volume, and length.
What are some good tools for measuring mass, Will?
A scale.
Very good. And the SI unit for mass is kilograms. What about volume?
A beaker.
No remediation is required.
Good. And the SI unit for volume is cubic centimeters, or sometimes liters. Now, what about length?
A ruler. Yeah.
Very good. And the SI unit is meter. Now, what about time?
Oh, it's my this thing. This has a stopwatch into it. Pretty good.
Very good. The SI unit for time is seconds. Now, temperature.
A thermometer.
Too good, sir. The SI unit for temperature is Kelvin, which is Celsius plus 273. Too good. Full mastery.
Woohoo.
No remediation required.
Now let's move on to uncertainty in measurements. As you can see, measurements aren't always 100% certain. There will be always uncertainty in measurement. The uncertainty of measurement is equal to 1/10 of the indicated intervals.
Very good. Now let us move on to another important part, significant figures. Draw some significant figures on the board, Will. Let's see if you have what it takes to become the Chem King. Excellent. As you can see, there's a specific rule on how you can count significant figures. All real numbers except 0 will count as one significant figure. If a zero is between two real numbers, then it's significant. If a 0 is before a decimal point, then it is also significant. Finally, any 0 that is after a real number, after the decimal point, is also significant. Any zeros after a decimal point and before a real number is not significant.
I'm so
Now,
nervous.
move on to adding and subtracting sig figs. As you can see, when adding and subtracting, the final result has to match up with the same number of decimal places as the original 2, the lower one. In multiplying and dividing, the final number sig figs must match with the sig figs with the least amount of the original 2 numbers. Excellent job, Will.
This kid thinks he's achieved complete mastery.
He ain't even close. Now on to the SI units. SI units are just System International units, or the modern form of metric units most widely utilized. As you all know, instead of using America's imperial systems, the world uses the metric system. Hence, we see centimeters and kilograms instead of inches and pounds. Thus, we will discuss some of the simple terms regarding metric prefixes and conversion factors. Of course, from the base SI units, we can derive it into different units. Will, show how velocity is derived.
Velocity is a d over time. And d
Excellent
stands for
job.
distance.
Now on to the most important part of any measurement. What is the difference between accurate data and precise data?
Ooh. Okay, so you see, accuracy is saying that we hit that target, and we hit that target, that's accurate. But if, let's say, but you see, precise is saying that if I hit this target, I hit 3 targets at the same point, then that's precise. See, that thing is precise but not accurate. And let's say if I hit different targets here, this is neither precise or accurate.
Well, so as you can see, precision is how much series of data are related to each other, while accuracy is how close a measurement comes close to the actual value. Let us see the demonstration, which you just did. Very good.
Now essential to the scientific process for someone like you, an aspiring chem king, is to be able to differentiate between mass and weight.
Do you have any idea how to do so, Will?
Differentiate mass and weight.
You have no idea, do you?
I'm actually really stupid.
Mass is the amount of matter in an object, while weight is the force of gravity exerted on an object.
Now, for a fat individual like Sir William, do you know what the difference between specific gravity and density is?
Ain't nobody got time for that.
Of course, we must sometimes calculate density of objects.
Density. D. Density. Mass over volume.
Excellent.
I'm sorry.
Finally, kiddies, we must understand percent error. As you can see, nothing is perfect, and thus it is crucial to understand what is percent error. Observe as Will calculates the percent error between 69 and 68.9.
As you can see, there are two types of data, theorized data and experimental. The experimental data can have errors because there can be many external factors in the lab that will affect the result. To find percent error, we will follow the formula of the absolute value of the difference between the theorized data and the experimental data. Then divide by the theorized data and multiply by 100.
I'm too lazy to.
This will be all for Act 1. Stay tuned for more.
Thank you.